the sounds of a major industrial fire. The kinds of sounds we don't like to hear. Every year the same scene is played out and the same sounds are heard hundreds of times. The damage reports, too, sound much the same. Gutted buildings, heat-distorted equipment, burned up product, missing revenues, lost jobs, injuries, and in some cases even loss of life. On an annual basis, fire-related damages run into hundreds of millions of dollars. But the statistics really don't tell the whole story. They don't tell you how many fires were avoided by thorough pre-fire planning. They also don't tell you how many small fires were extinguished before they had a chance to grow into major blazes. The fact is that most major fires start small, and that most of these fires could have been extinguished had they been discovered on time and the appropriate actions taken. When it comes to extinguishing a fire in its early or incipient stages, the first line of defense is usually this: a hand-portable fire extinguisher. Knowing how to locate and operate one of these extinguishers often spells the difference between a minor fire and a major catastrophe. In this program, we'll be introducing you to several different types of portable fire extinguishers. You'll learn about the different kinds of firefighting agents that are used in portable fire extinguishers and which types of fires these agents can effectively extinguish. We'll also be showing you how to operate a portable extinguisher and how to attack a fire using the proper firefighting tactics and strategy. Let's start by reviewing the basic components of fire. A fire occurs when fuel, oxygen, and a source of ignition are brought together at the same time and in the right proportions. These three ingredients make up a fire triangle. While only three things are needed to start a fire, a fourth component is required to keep a fire burning after it's started. This fourth component is a chemical chain reaction that occurs between the fuel and oxygen during the combustion process. This essential fire reaction is called oxidation. So four things are needed to sustain ongoing combustion. If any of these four ingredients are removed, a fire will die. The way to extinguish a fire, then, is to take away one of the ingredients that allowed it to start. A fire can be quenched by cooling the temperature of the fuel. It can be smothered by removing oxygen. A fire can be starved by cutting off the supply of fuel. Or it can be inhibited by interrupting the chemical chain reaction of combustion. So there are four different ways to extinguish a fire: quenching, smothering, starving, and inhibiting. Every firefighting agent utilizes one or more of these methods to stop combustion. Let's take a look at the firefighting agents that are used in portable extinguishers and see how they work. The oldest, cheapest, and most plentiful firefighting agent is water. The extinguishing action of water is based primarily on the removal of heat. The burning fuel is cooled by the water to a point where it no longer produces combustible vapors, and the fire dies. Another fire extinguishing agent is carbon dioxide. When carbon dioxide is applied to a fire, it dilutes the oxygen content in the air to a level that will not support combustion. So CO2 is basically a smothering agent. A third extinguishing agent is foam. When foam is floated over the surface of a burning liquid, it forms an insulating blanket that prevents air from mixing with the fuel and prevents fuel vapors from feeding the flames. Water mixed with the foam also helps to cool the fire. Foam utilizes a combination of extinguishing methods to put out a fire. These are starving, smothering, and quenching. Dry chemicals are a fourth type of extinguishing agent. These are powdery substances that have the ability to interrupt the chemical chain reaction of combustion. So dry chemicals are classified as inhibiting agents. Halogenated agents are another group of inhibiting compounds. The vital ingredients in these compounds are fluorine, chlorine, and bromine, which work chemically to stop the oxidation reaction of fire. When this reaction is halted, a fire quickly dies out. Most halogenated agents are stored as a liquid under pressure and then convert to a gas when released at atmospheric pressure. The last group of extinguishing agents are dry powders. Dry powders are specifically designed to extinguish combustible metal fires. When applied to a fire, they form a coating over the burning metal which smothers the fire. So there are 6 types of agents that can be used in portable fire extinguishers: water, foam, CO2, dry chemical, halogenated agents, and dry powders. But how do you know which agent is best for a particular type of fire? Unfortunately, there's no one pat answer to this question. First, you need to determine what kind of fuel is burning and decide whether the agent is effective on that type of fire. Then you must take into account any factors that might affect how the agent is applied, such as the location and configuration of the fire. Suppose you encounter a fire involving gasoline spraying out of a ruptured pipe. Although water is an outstanding coolant, it's ineffective on fires that involve fuels with low flash points. If water is applied to burning gasoline, the fuel will continue to release flammable vapors. So normally a gasoline fire cannot be extinguished by cooling. Foam is effective on gasoline fires, but the burning fuel must be on a flat surface in order for the foam to form a vapor-tight seal. Gasoline spraying out of the pipe cannot be effectively covered with a layer of foam. The best extinguishing agent for this type of fire would in most cases be dry chemical. Every fire extinguisher has a label that tells you what class of fire that extinguisher is designed to control and extinguish. Extinguishers with a Class A rating can be used on ordinary combustible materials like wood and paper. A Class B rating means the extinguisher is effective on flammable liquid and gas fires. If a fire involves energized electrical equipment, a Class C extinguisher is required. Class D extinguishers are designed for combustible metal fires. Some portable fire extinguishers are capable of fighting several different classes of fires. Multipurpose dry chemicals, for example, carry an ABC rating. An extinguisher with this type of agent can be used on any fire as long as it doesn't involve combustible metals. You should familiarize yourself with the capability of the fire extinguishers in your work area. This is especially important if there are different extinguishers for you to choose from. Let's start with water-based extinguishers. There are 2 basic types of water-based extinguishers: stored pressure extinguishers and pump pressure models. In a stored pressure extinguisher, there's a single chamber that contains both the water and an expellant gas, which is usually air. When the operating lever is squeezed, the expellant gas pushes the water up the siphon or pickup tube and out through the hose and nozzle. The operation of a stored pressure water extinguisher is fairly simple. First, you pull out the ring pin. Then you grasp the hose with one hand and actuate the extinguisher by squeezing the discharge lever with the other hand. Here's a diagram of a pump-type water extinguisher. This type of extinguisher utilizes a built-in pump to discharge the water. Usually the pump is double-acting, so that water is discharged on both the up and down strokes. To operate this type of extinguisher, you simply move the pump handle up and down. Water-based extinguishers have a fairly long range and discharge time. Their range usually varies from 30 to 40 feet, while the discharge time lasts a minute or more. To extinguish a fire with a water-based extinguisher, you direct the agent at the base of the flames and move the stream in a side-to-side motion. As the flames are extinguished, carefully work closer to the fire. For additional cooling, you can hold your fingertip over the nozzle to create a fine spray. Although a fine spray travels less distance than a solid stream, it is more effective on glowing embers. Water-type extinguishers should only be used on Class A fires. If water is applied on a Class B fuel, it might actually spread the fire. Water on a Class C fire is particularly dangerous because it could result in a fatal electrical shock. An effective agent for fires that involve flammable liquids and gases or energized electrical equipment is carbon dioxide, CO2. When carbon dioxide is applied to a fire, it dilutes or excludes oxygen that would otherwise react with the fuel vapors during combustion. The fire is extinguished when not enough oxygen is available in the atmosphere to support combustion. The agent in a CO2 extinguisher is stored as a liquid under extremely high pressures. When the extinguisher is open to atmospheric pressure, about 75% of the liquid is converted into a vapor that is self-expelling. The remaining 25% of the CO2 converts into ice particles that are expelled with the vapor through the discharge horn. To activate a CO2 extinguisher, you remove the ring pin and then squeeze the operating lever. You should never handle the discharge horn because it'll become extremely cold as the dry ice particles flow through it. Because wind currents and drafts can disperse carbon dioxide, this type of extinguisher has a rather limited range, usually not more than 8 feet. This means that you should apply the agent as close to the base of the fire as possible for the best extinguishing results. After the flames are extinguished, you should continue applying the agent to prevent reignition. When carbon dioxide is applied in an enclosed area, it may be necessary for personnel to wear protective breathing equipment. This is because CO2 can reduce the oxygen content of the air to a level that isn't safe for humans. After the fire is extinguished, you should ventilate the area to disperse the CO2. In the 1940s, an agent which is not greatly affected by wind currents and doesn't displace oxygen became popular. This agent was dry chemical. Dry chemicals inhibit the chemical chain reaction of combustion and are primarily for use on Class B and Class C fires. Multi-purpose dry chemicals are also available, which are effective on Class A, B, or C fires. On Class A fires, the multi-purpose agent forms a coating over the burning material which smothers the fire. There are two different designs for dry chemical extinguishers. This is the stored pressure type. In this type of extinguisher, the dry chemical and the expellant gas are mixed within the same shell. When the operating lever is squeezed, the gas forces the dry chemical up the discharge tube and out through the hose and nozzle. The second type of dry chemical extinguisher is a cartridge-operated model. The cartridge contains the expellant gas, which is usually CO2 or nitrogen. When the puncture lever is depressed, gas flows into the agent chamber and pressurizes the extinguisher. The discharge of dry chemical is controlled by a nozzle at the end of the hose. When you apply the agent, stand back about 8 to 10 feet from the near edge of the fire and direct the chemical at the base of the flames. Moving the nozzle from side to side, gradually advance on the fire as the flames are knocked down. If ordinary dry chemicals are being applied to a fire that involves Class A fuels, the chemical agent should be supplemented with a fine water spray. The water will extinguish any Class A materials and prevent them from becoming a source of reignition. Multi-purpose dry chemicals normally do not have to be accompanied with a water spray. These multi-purpose chemicals are effective on burning wood and other ordinary combustibles. About the only disadvantage of dry chemicals is that they leave a residue which can damage sensitive electrical components. When the area to be protected contains such equipment, a halogenated agent extinguisher is often the best choice. This is because halons are clean agents that extinguish without leaving any residue. Halogenated agents work by interrupting the chemical chain reaction of combustion. Although most halons are designed for Class B and C fires only, some of these agents, like Halon 1211, can extinguish Class A fires also. A halogenated agent extinguisher is designed and operates much like a CO2 extinguisher. Halon 1211 is stored as a liquid under pressure. When the extinguisher is activated, the liquid is converted into a vapor that is basically self-propelling. A charge of nitrogen is added to help boost the self-propulsion of the gas. Halogenated agents have about twice the range of CO2 extinguishers and are less likely to be adversely dispersed by wind currents. A disadvantage of Halon 1211 is that its vapors are toxic in moderate concentrations. So, when applied in enclosed areas, you should avoid breathing the vapors and ventilate the area as soon as the fire is out. Some fire extinguishers use foam as the extinguishing agent. Foam extinguishers are effective on Class A and B fires. When the foam is applied to a burning fuel, it forms a vapor-tight seal that smothers and starves the fire. Water in the foam also helps to cool the fire. The foam used in these types of extinguishers is called AFFF, which stands for aqueous film forming foam. AFFF and water are stored in the same chamber inside the extinguisher. When the extinguisher is activated, an expellant gas forces the solution through an aspirating nozzle which mechanically produces the foam. Whenever possible, foam should be applied gently to a burning liquid. If the foam is splashed into the fire, the agitation may break up the vapor-tight seal. On flammable liquid fires, the best technique is to impact the foam against a surface that is above and behind the fire. This will allow the foam to flow back across the burning with a natural spread. You should never apply foam to a fire that involves energized electrical equipment. This is because water in the foam conducts electricity and is capable of transmitting a fatal electrical shock. The last type of extinguisher we'll look at is a dry powder extinguisher. Dry powders are smothering agents that are used on combustible metal fires. A dry powder extinguisher is very similar to a cartridge-operated dry chemical model. The powder is stored in the main shell, while the expellant gas is held in a separate cartridge. The extinguisher is pressurized by puncturing the cartridge and releasing the gas. The agent should be applied from a safe distance with a fully open nozzle. As the fire comes under control, you should throttle the nozzle valve to produce a soft, heavy flow. The metal can then be thoroughly covered with a heavy layer of dry powder at close range. The technique for fighting most Class A fires is basically the same. You start at the base of the fire and gradually cover all of the burning material. If possible, you should apply the water as a fine spray instead of a solid stream because the spray will absorb more heat. When materials like wood burn, the combustion reaction actually penetrates the surface of the fuel, so after the flame is gone, combustion may continue in the form of glowing embers or hot smoldering ashes. These embers can cause reignition, so it's important to thoroughly quench them with water. Sometimes the easiest way to get at the deep-seated combustion is to actually break up the materials. Let's move on to Class B fires. The techniques you use to extinguish these types of fires will vary depending on the type of fuel that's burning and the physical characteristics of the fire. One type of Class B fire is an uncontained flammable liquid spill fire. Spill fires often occur underneath leaking equipment such as compressors, turbines, and storage drums. Accidental spillage around storage and processing equipment can also lead to a spill fire. You can use foam, halons, or CO2 to extinguish a spill fire, but the best general agent for fighting flammable liquid and gas fires has, over the years, proven to be dry chemical. If dry chemical is going to be used on a spill fire, stand back at least 8 to 10 feet from the fire before you begin applying the agent. If it's possible, you should approach the spill from the upwind side. Aim the dry chemical so that it lands about 6 inches in front of the fire, while rapidly moving the stream back and forth across the base of the flames. Each sweep of the dry chemical should be slightly wider than the outer edge of the fire. Advance on the spill as the flames are knocked down. To extinguish the small fire at the back edge of the spill, aim the chemical directly at the flame base. If an obstacle is introduced into a spill fire, 2 operators will have to work together to extinguish the blaze. A single operator using dry chemical cannot reach the burning material behind the obstacle. As he circles around the obstruction, the fire keeps spreading to an area that's shielded from the agent. To extinguish this fire, the operators advance around each side of the obstacle. The fire behind the obstruction is then extinguished by aiming both streams directly at the base of the flames. Another type of flammable liquid fire occurs when fuel is held within some type of container. This type of fire is often called an in-depth fire because the liquid in the container is usually deeper than an uncontained spill. In-depth fires typically occur in tanks, dikes, and pans which hold flammable liquids. Flammable liquid in-depth fires are more difficult to extinguish than spill fires because the edge of the container will often interfere with the application of the fire suppression agent. Also, care must be taken to avoid splashing the burning liquid over the edge of the container. Typically, the same strategy is used to fight both spill and in-depth fires. The agent should be applied with a sweeping motion that gradually works the flames into a back corner of the container where the fire is extinguished. A third type of flammable liquid fire is a three-dimensional gravity flow fire. This type of fire involves a burning liquid, which is spilling out of a ruptured or overflowing piece of equipment. In this situation, there are actually two different fires to deal with. The first is the burning fuel flowing out of the tank, while the second is a spill fire underneath the equipment. Another complication is that the equipment supports may serve as an obstacle, in which case two operators will be required to put out the fire. The way to extinguish this type of fire is to start with the fuel burning on the ground and then work up to the fuel source. Using a sweeping motion, you apply dry chemical across the base of the flames and extinguish the ground level fire first. Then you gradually work up the gravity flow portion of the fire until it has been extinguished at its source. If there are any hot metal surfaces or glowing embers in contact with the fuel, it may also be necessary to supplement the dry chemical with a fine water spray. This spray will cool any hot materials that could serve as a source of reignition. A fourth type of Class B fire involves flammable liquids or gases that are under pressure. Pressure fires are easy to identify because the burning fuel sprays out from the fire source. Pressure fires are often caused by seal and gasket failures in pumps, compressors, valves, and piping systems. When flammable liquids are on fire, burning fuel will usually pool on the ground. The procedure for extinguishing a pressure fire is just the opposite of a gravity flow fire. You start at the source of the escaping liquid and then work down to the ground level fire. If you attempt to extinguish the ground level fire first, the burning fuel spraying out from the source will keep reigniting the spill. When a flammable gas is burning, you follow the same strategy that's used to extinguish a liquid pressure fire, even though a ground fire is not produced by the escaping gas. First, you direct the dry chemical at the fuel source and then follow the flame outward. If it's not possible to shut off the fuel supply, it's often best to let a pressure fire burn. This is especially true for flammable gas fires. If a pressure fire is extinguished without shutting off the fuel, large accumulations of flammable liquid or gas may form, which poses a serious hazard. It's often safer to allow a controlled burn because the fire will consume the fuel until it can be shut off. The last type of fire we'll look at involves live electrical equipment. The best agents for fighting live electrical fires are CO2 or halons. These are clean agents which won't damage the equipment, and more importantly, from a life safety standpoint, do not conduct electricity. When you're dealing with a live electrical fire, the first thing you should do is turn off the source of power, if this is possible. Using rapid sweeping motion, apply the agent across the base of the fire until all the flames have been extinguished. If any Class A materials are involved in the fire, you may need to cool these with water to avoid reignition. Before you apply water to the fire, however, be sure that the source of power has been turned off. Portable fire extinguishers are a vital weapon in every plant's arsenal of fire protection equipment. They may not be needed often, but when they are, it's essential that they be easy to locate and operate properly. There are several things that you can do to make sure the extinguishers are there in good working order when you need them. First off, you can make sure that extinguishers are where they should be by periodically checking their location. It's important that extinguishers not be obstructed by furniture, equipment, or anything else that could make them difficult to see or reach. You should check the extinguisher seal to see that it's still intact. If the seal's been broken, the extinguisher may have already been used and the agent depleted. Also check for any obvious physical damage, like a broken valve or nozzle, severe corrosion, or a deteriorated hose. Many extinguishers are equipped with a pressure gauge that'll tell you if the extinguisher is properly charged. Check the gauge and make certain there's always a full charge. Periodically, a fire extinguisher should be taken apart, inspected, and cleaned. This type of maintenance should only be performed by a qualified person within your organization or by an authorized fire extinguisher servicing company. Periodic maintenance is normally scheduled at 1-year intervals or after each time an extinguisher has been used. This concludes the audio-visual portion of our program on portable fire extinguishers. In the course of the program, we've introduced you to 6 different types of extinguishers and shown you how they work. You've learned about the different kinds of firefighting agents that are used in these extinguishers and which types of fires these agents are capable of extinguishing. And finally, we've shown you how to operate portable fire extinguishers and how to attack a fire using the proper firefighting tactics and strategy. We hope this program will help prepare you to deal with any fire emergency. And when it comes to being prepared, portable fire extinguishers are a key part of the total game plan.